Okay. So before we get to the secant line, I'm sure you're all familiar with finding slope, right? Do you remember this formula, y2 minus y1 over x2 minus x1? The change in y over the change in x. I'm pretty sure this was drilled into you in middle school and high school, and it keeps coming up, right? So the idea was if you had a straight line, right? We only looked at straight lines back then. The slope would be the same, right? Because you'd have 2 points, and you would find the slope connecting the 2 points, and that'd be the rate of the entire line. But as you can see here, we now have curves, and that's why we have to start doing calculus, because we have more complicated functions. In real life scenarios, right, or things that represent real life things are not pretty, so we have to complicate things. So here we go. So if you use the slope formula, it's also called the average rate of change for a general function. So let's say I picked any 2 points and say, you know what, what's the slope that connects those 2 points? That's called the slope of the secant line, right? But it's not really the rate of the function at either point. It is the average rate from A to B, or x0 to x1, whatever, or first point to the second point. Now the tangent line, which is what we're going to talk about today. So secant was from college algebra or before that. Tangent line is the slope right next to a point. So for example, the slope going down here would be negative because it's decreasing. The slope going this way would be positive because it is increasing, right? So finding a slope at any given point, a slope tangent to a point is called the slope of the tangent line. Okay, so that's what we're going to do. So the idea, the theory behind this is, what happens if I create a limit that allows this distance here, the distance between here and here, go to 0. If it goes to 0, the limit, then I can find a slope at a single spot instead of an average slope connecting 2 spots. So you're basically letting these 2 points equal to each other. You're letting it go to 0. And that's what we're going to show with the limits. So they do that right here. We're going to do this in just a minute. So that the limit of the denominator go to 0. And once that's gone, you have some delta x. So we're going to call this h just to make it prettier and more simple. So that's the idea. We're shrinking that distance until it becomes 0 distance. They're thus giving you the slope at that point. Does the theory make sense? And of course, there's a bunch of videos I posted and examples with that. I hope you watched it. So we're going to work on the mechanics, like how does it work and how do you find it? But I just want to make sure I go over a little bit in case you did not see the video. You guys have any questions on that?
No, sir.
Okay. Let's start. Let's get to it. The examples in the homework, 3.1. Example 1. I'm going to pick, so from the homework, problem 3. It's 3.1, right? So find, I can't see where I'm writing. 1 second. Okay. Find the slope of the tangent line to the graph of the function. So the only reason we actually went over limits and studied them was in order to apply it to this idea. But they're also useful, but that's the main reason is this. To find the slope tangent to a graph. So here is the question. Okay. So they want to know the slope tangent to this point. So let me just before we start, show you a picture. I want you to imagine this. This is what I just wrote on the paper. 3x squared minus 6. And we care about the point 3, 21. Right here. So basically, if I can draw or not, I'm gonna try though. I want the slope that's right next to this point here. So if you imagine a line being right next to it, what is the slope of that line, right? It's probably better if I zoom in. Let me redo that. Okay, so I want to know the slope right here next to this point. Okay, so it's not vertical, it has a slant to it. I just can't really draw. All right, so it's going, what is that slope going this way? That looks better. Does that make sense what we're looking for? That's what we're about to do. Find the slope of this tangent line. So in order to do so, we need to find the limit of the difference quotient and then plug in 3. Okay. So this is what you have to do. You have to find the limit of f of x. Oh, actually, f of x, I'm going to use h because I think it's neater. The notes in the book and the examples in the book, they're going to use delta x, and I don't like it personally. You can use whatever you want when you do it. I don't care. I'm just going to use h. So the limit as h goes to 0, find the limit as f of x plus h minus f of x is on top. Once you do all the simplification, plug all this in, you take the limit at the very end, you will find the derivative function. So this right here is equal to the derivative, which we will denote with a little prime quote. Okay. All right, so what I recommend is find x plus h first, because that's, if let's say your algebra is not the greatest, so let's do it all piece by piece just in case. If you're a pro, you can do it all at once. It doesn't matter to me. So I'm doing this piece first. FOIL that out, multiply it out. That's x squared plus 2xh plus h squared times the 3 still in the front. That will give me 3x squared. Yeah, there's not enough space. Let me skip a line here. One moment. There we go. So that'll be 3x squared plus 6xh plus 3h squared minus 6. And of course, f is already given. There's nothing to do there, right? It's just this. So we're going to plug this in up top here, and then subtract the original. That's all we're going to do. So the limit as h approaches 0, right, as h goes to 0. I'm going to write it one more time just for no reason. So that equals the limit. Let's put it down here. The limit as h approaches 0. So it's going to be 3x squared plus 6xh plus 3h squared minus 6 minus the f of x, right? So minus that whole thing, to put it in parentheses, over h. So at this point, you guys still with me? All I did was find this and plugged it in here, and then plugged in the original function there. Is the algebra okay?
Yes, sir.
Yeah.
Let me know if I went too fast or if I skipped something. No big deal. Okay. So stop in at any point. So at this point, we're going to distribute the negative. So that becomes 3x squared plus 6xh plus 3h squared minus 6 minus 3x squared plus 6 when you distribute that negative. So you see what's going to cancel, right? The 3x squares are gone. The 6's are gone. So now that equals the limit as h goes to 0 of 6xh plus 3h squared. So notice we're almost done, right? You can factor in h on the top. It's almost like those removable types that we were doing a couple of sections ago. So I'm going to remove that h, factor it out, right? Now it's gone. Now you can see that you can now take the limit, right? Just plug in you let h go to 0. So you're left with 6x. So this is the derivative.
And the h went to 0 because obviously 3 times 0 is 0, right? And that's why it's 6x.
Right, you
Okay.
finally take the limit and this goes away.
Gotcha. Okay, cool.
So this is the long way of finding 6x derivative. Okay. But that's, so we did all this just to find the derivative. The derivative is what gives us slopes of the tangent line. So we just plug in the 3 in here. So let's do that on the next page here. So put it in.
Can I copy that bottom
yeah.
part?
Yeah, no
Sorry.
rush, sorry. Go for it. So all you gotta do is plug in the 3 and we'll be done.
So you said for the exam, you have one question where we actually have to use the actual, like, explaining it all like this.
Yeah, you're gonna have to use well, there's one example where you have to use limits to find the derivative. But the rest will just be the basic rules that we're gonna go over in a little bit.
I'm kind of lost on the very last step. What happened to the 3h? Because I see where 6x came from, but
Oh, yeah, you just take the limit that goes to 0. When you take the limit, you plug in the 0, right?
oh, okay, because it's approaching 0.
Mhm. Yeah, since it's no longer on the bottom, I canceled it. So you're able to just go ahead and plug it in. So whenever you do these, the goal every single time is to cancel that h on the bottom. It's gonna cancel every single time. And if you can't, then you probably made some sort of weird error at the beginning or somewhere.
Okay, I'm good.
Okay, so the question said find the slope of the tangent line. So to find, let's just put it in plain English, to find the slope of a tangent line at a given point, just plug in x into f prime. So they gave us this point, right? So we have the derivative of 6x, and we had a point of 321, right? So f prime of 3 is equal to 6 times 3, which is the slope. Sorry, I got a blurry on there for a second.
And you're using 3 from the 3H, right? Or where did you get the 3 from?
3 was the point they gave me at the very beginning,
Oh,
321.
okay, so you 6x
yeah.
from our previous answer, and then we took 3 from the
Yeah.
point, okay. Okay,
Yeah, so we get back to that graph, right? So the slope of this line, no, of the line tangent to this point is 18. So we need that location, the 3. And then this is the question we're working on. So they're just gonna ask you to find the slope of the tangent line at a given point. So you find the derivative of this function, and then you plug in the 3. And that's how I like you to approach it. Number 2, 3, and 4 are the same. It's just they're different functions. This one was the harder one. Also, this constant, the derivative of any constant, it does tell you to use a limit process. So you should, but you should know that derivative of any constant is going to be 0 because there is no rate of change. It's literally a constant. That's why it's called that, right? So it's going to be 0. Any questions on using the limit to find the derivative?
so was this the short way you just showed us, or were you getting to that?
Now we're about to do it.
Okay, cool, just making sure. I was like,
I mean, that was my definition.
okay, no
So
problem, making sure.
I guess that is another short way. Let's see here. So a shortcut, right? All right, so number 1, the derivative of any constant is 0. So if your function is equal to some constant c, f prime of that function is 0, where c is some real number, some element of R. You guys, I forget if I use this notation in this class or not. C epsilon capital R.
I mean, isn't that the right way to use it?
Yeah, I mean, if you're not comfortable, all this means is C is any real number in plain English.
Oh, yeah, for sure.
Okay, the power rule is the main one we're going to use today. So if you have a function where x equal to x to the n, the derivative will always be the following. You bring down the n and subtract 1. Where n is an element of the real numbers. Just in case it comes up. I mean, I don't think this is necessary, but I figure an extra note just for fun. Let's say you had some number in front right? The derivative would just be multiplied times, or the power multiplied times a c. So it'd be c times n minus 1, where c and n are an element of the real numbers. So that should be enough for all of chapter 3.1 and probably 3.2. You will see some functions where you can't, let me show you, use these rules. You need more complicated rules. But check it out. These you could do it no problem. Same here. This one you can't without using more advanced rules, which we haven't got to. That's later in chapter 3. So you have to do the limit because we don't have a technique for it yet. Same thing here. This is a square root function, so you're going to have to use the limit process that I showed you. Only those, yeah, it looks like only those two for the most part. Yeah. Okay, so let's do a few examples using the new rule. Let's do number 5 and 6, or maybe just 5. Find the derivative. Oh, one moment. Okay. Find the derivative of the function f of x equal to x squared plus x minus 2. So the power rule can be used on each term separately. So the derivative of f of x, right? You just bring the 2 down on the power, and then you subtract 1 from the power. Plus bring a 1 down because that's excuse me, that's what's on the x there. 1 minus 1. And the derivative of a constant, of course, is 0. So this should be 2x plus x to the 0, which we know is a 1, right? Any questions on how we got to here?
So we put the 2's there because obviously x squared was just 2, and that's why we put 2 minus 1 because that was the power rule, right?
Yeah, and you bring the whatever's up top, you put it in front, and then you subtract by 1. And so we did up here in general, right? We said whatever n is here, we bring it down, subtract 1.
Okay.
So that's all we're doing.
And that's why there was 1 minus 1 on the x, right?
Yeah, since if it's just a normal x, right? Technically there's a 1 up there, so you bring a 1 down, subtract 1. It's just going to be 1. Whenever I see just an x, a single power, I just make it a 1 right away. But this is y. And any constant again is 0.
And why did the 2 become a 0 at the end?
That's the first rule.
Oh, okay, I see.
So whenever you see a number, it doesn't matter what it is, it's going to be 0 if you take a derivative. Could be pi, it could be a fraction, a decimal, whatever.
Okay.
Okay. So that wasn't too bad, right? So they asked us to find a limit process, but we used our power rule. Any other questions on number 2?
Would you mind working out that one problem below the one you just provided? I just saw like a glimpse of it.
Oh, yeah, number 6, sure,
Yes, sir.
let's do it. Okay. Find the derivative of f of x equal to 2x cubed plus 4x squared. So to find the derivative f prime, we have to use our power rules, right? So you have a 2 up there, so you bring the 3 down and subtract the 3 by 1. Plus 4, bring the 2 down, subtract that 2 up there by 1. So next step, that would be 6x squared plus 8x. Which is what they got, right? But they used the limit, and we did not. Any questions on this example? Okay, let's see. Let me find
Actually, for number 3, I was looking at number 3, it says 5/9x plus 2. If you were to use that rule, the power rule, how would you do that to a fraction?
number 3, you said?
Yes, sir. Because it's
Uh,
5, mine says 5/9x plus 2. And then I also don't know how.
you're talking about
the-
well, mine might be different. Were you talking about number 2? This one here?
Yes, sir. Yes, sir.
Oh, you know what?
here's-
I'm actually editing this homework as I'm going along, so I deleted number 2. So my number 2 is number 3. I'm sorry. Let me save it. Hit refresh on your screen, that way it'll be gone. So this guy here, see how there's a single power there?
Yes,
You
sir.
would bring down to 1, so it'd be 1 times 4 sevenths, and this would become just a 1, right? Because you'd have 0 power.
Mhm.
So this would just disappear, leaving you with 4 sevenths. This would be 0.
Oh, okay. So 4/7. I get it. Okay, so 4/7 to GPU. All right. I get
Yeah,
it.
it's just like the X we did.
So- yeah, I get you. Okay, that makes sense. Total sense. My bad.
Yeah, no worries. Like if it was a 3x, derivative of 3x would be 3. And you'd have a 3 here. Okay, so the other thing they want you to do in this homework is find the equation of the tangent line. So let me find a simple one to start off with. You guys remember how to find equations of lines from, this is probably from before college algebra? A long time ago.
Wait, what did you say for what? For algebra?
Do you remember how to find an equation of a line?
Was it the line? You mean like the slope or just the line?
And you have both, like given 2 points or given some information. Do you remember finding the M and the B and all that stuff?
Oh, like mx plus b?
Yeah, all that stuff. All the line equations and ideas.
I would say somewhat.
Because that's basically what we're gonna do. We're gonna do the exact same thing from way back then. The only thing is our M is the slope of the tangent line. That's all. It's the only difference. So it should look very familiar once we start in just a second. Here we go. This one looks like an easy one. To start with. Find the equation of the tangent line given that f of x is equal to x squared plus 3, and they give you a point of -1, 4. Okay, so first thing you have to do is find the derivative, plug in the x to get the slope. So we're basically looking for this, right? Or if you prefer, the other equation, what was it? Shoot.
Y2 minus y1.
Yeah, close. That's why it's the point slope form. That's what I was trying to say. Sorry. M times x minus x1. So this one, some people prefer this to find equations of lines. You can use this if you want. If you feel a little rusty on finding line equations, this one's easier. If it doesn't matter to you, either is fine. So the only thing is m needs to be found with the derivative. Well, x1 and y1 are given right here, right? This is x1, y1. So what is the derivative? It's x squared plus 3. Derivative of x squared. You have to bring the 2 down and that constant becomes a 0, right? Okay. M of the, I'm gonna call it M tangent, is equal to the derivative at -1, which is equal to 2 times -1. So there's my M. So use, I recommend use this slope and the point slope formula to find the equation of the tangent line. Okay, so just plug it all in, right? So y minus y1 is equal to m times x minus x1. y1 is 4, so y minus 4 is equal to m we found to be -2, x minus x1, which is a -1. And there it is. So we plug it all in. Plugged in our x1, y1, and our slope. Any questions up to this point? Because that's okay. So this point is just basic algebra, right? We've already, this is the answer technically, but we should solve for y because the homework is not going to take this weirdness. So let's do our algebra. I'll show a couple of steps here. Minus minus is a plus, so it'd be -2 times x plus 1. Y minus 4 is equal to -2x minus 2. Add the 4 over, right? It's old school. Y is equal to -2x plus 2. So this is the equation of the tangent line. Let me show you visually. Just a moment. Two x squared, right? No. Yeah, x squared plus 3. The point they gave us was -1, 4. Okay, so let's put it all together. What the heck did we just do? And what does it mean? Here. So we were given a function, this parabola, right? And they wanted to know what is the tangent line, which is the purple line, tangent to this point. And we did the math to solve for this equation. So now we know exactly what the line tangent to this point is, like right next to it. So you see what I mean? So that's how you find a tangent line. And that's what a tangent line is. Any questions about number 4? Damn.
So this one's finding tangent line, and then the other one that we did was finding the slope of the tangent line, correct? I just want to make
Right.
sure like those are the
Right. The first couple of examples. Well, the first example was finding the slope of a tangent line. The other examples are just finding the derivative.
Oh yeah, I'm sorry, I'm not just that's because these are very similar. It was just the wording made it different on what we were looking for.
Yeah, no, I get you. Let's go through it just real quick. So let me show you. Just to be clear, right? So the first 3 questions are just saying find the slope. Or sorry, first 2. Find the slope at this point, tangent to this graph. So you find the derivative and you plug in the number. So that process is pretty much the same for all the examples. You have to find the derivative and plug in the point, except for these 3 here. They just want the function, the derivative of the function, and that's it. You don't actually do anything with it, right? And then over here, here you find the derivative, plug in the 10, and then you find the slope and the whatever. The same thing we just did here. They just used this function instead of a parabola. I think these are the ones that we're gonna do next, though. Any questions on finding the tangent line equation?
For the one that showed the graph, I was trying to figure out how they got, what was it? Yeah, x minus 10 over 6 plus 3.
Well, they did a bunch of algebra. They're not showing us, but
Oh,
what they do is you find the derivative first. Here you have to do the limit process. So do the limit, find f prime, plug in 10. Once you plug in 10, you're going to use this formula here. Once you find the slope, right? You're going to use this guy. So you plug in the m and that point they gave us, which is 10 comma 3. And then you just go through this work. Then you should get something like 10 minus x minus 10 over 6 or whatever, or something similar.
okay.
So finding derivatives square roots, like is that follow power rule? Or
No, that one the power rule will not work on that one. You have to do a limit process.
oh,
Not at least not until we learn the other techniques, which we haven't done yet. I think in order to do it with a shortcut or a formula type technique, I think that's not till 3.4. So either you go read a few sections or you use the limit process. So yeah, I say just deal with it since you have to practice it anyway. I'll leave that for you. It's good practice. Does that make sense though, or? Okay. Number 9, 10, and 11. You have to remember what it means to be parallel. So here they actually give us the equation of the tangent line for number 9, 10, and 11. But they want us to find an equation that is parallel. Okay. So they don't give us a point. Right, notice that? All we have is the equation of a different line. Some rando line. And they want us to find the equation that is tangent to this graph, but also parallel to this line. That's what they want us to do. Do you remember what it means or how you know two lines are parallel?
I think it was something like if the slope forms are opposite.
It's close. The slopes have to be exactly the same for parallel. If it's perpendicular, then they're opposite and opposite signs and reciprocal. So pretty much complete opposite. But for parallel, they have to be exactly the same. Let's see here. Write you some quick notes in case you forgot. I was going to call them the lines y1 equal to m1 x next one plus b, and y2 equal to m2x plus b are parallel if m1 equals m2. They are orthogonal or perpendicular, whatever you prefer, if M1 is equal to the negative reciprocal of M2. Okay, so this part needs to make sense before we start the question, or you have to remember at least this fact here. Parallel, the slopes must be the same. This is example 5, I forgot. Yeah, 5. Example 5. Find an equation of the tangent line that is tangent to the graph of f and parallel to the given line. So here's the line, or the function, sorry, and here's the line. Okay, let's start off with the derivative because we're going to need that, right? So what's the derivative of f? This one's an easy one. Did this earlier.
2x.
Yeah, 2x, right? Okay. So what is the slope of this line? Can you tell we're looking at this line? Or what needs to be done first?
Do you need to get x by itself?
Close. We need to get the y by itself.
Oh, okay. I thought that was a 4.
Oh, it's a y. Oh, sorry, it's totally my fault. Okay, so move the y over. We're pretty much done, right? If you prefer, the y on this side. There it is. This is the same thing. This is the same equation as this one, right? What is the slope of this line?
Is it 8?
Yeah, it's going to be 8. So the slope m is 8 for this line. So this slope must equal the slope of the tangent line, right? Because they have to be parallel, so they both have to have 8. So this is kind of like this basically is like they're giving us a clue, right? And we have to find the x value using that information. So the way I want you to think about it is I'm looking for the x that would give me an 8 in the derivative, right? So what is the x value that would make this 8?
4.
Yeah, right. You just solve for x. You have 4. So at 4, the derivative will give me 8, which will equal the slope of this random line. And if I have equal slopes, then they will be tangent to each other. That's the requirement. So I'm using that requirement of parallel, right? To figure out what the heck the x is. So it's a little weird if you don't remember a lot of this stuff, because you have to remember, okay, y-intercept form, the slope is always whatever is on the x. Once you solve for y, you have to remember what it means to be parallel. And then you have to remember the new ideas of how derivatives gives you a bunch of slopes at any given point of some f. So all those ideas need to be in play before we start solving it, right? Because we're looking for some line that's parallel to this and tangent to the graph. So we have to use the same process we did to find the tangent line. We're just using this idea. But once you have x, how do you find the y?
Slope point form.
We're going to use this. We're going to use that in just a moment, but we need the y value first. So I have an x, but I don't have the y.
Would you just substitute the x with 4?
Yeah, just plug this guy here to get the y value. So f of 4 is equal to 4. Let me do it over here. So I'll get this confused. F of 4 is equal to 4 squared, which is 16. So this is my y value. So I have my m, which is 8. M is equal to 8. I have my x equal to 4. My y equal to 16. So now I can find the equation, right? Y minus y1. I need those 3 pieces, and I got them. It's just that I feel like finding the x requires a lot of ideas. And I want to make sure you see how this came about. Because the rest is not that bad. Is that clear?
Yes, sir.
Okay, cool. So I was worried it was really weird or something. One sec. All right, we'll just plug it in and we're done, right? So 16, 8, 4. 16, distribute the 8, that'd be 8x minus 24. So y is equal to 8x minus 24 plus 16 when I add the 16 over.
Would that be 32?
Yes, thank you. Sorry, I don't like numbers that much. There we go. 32. 32. Okay. So 8x, so negative 32 plus 16 is negative 16. All right, so let's see what this all looks like, right? 'Cause okay, we have x squared. Just so you can see what's happening, because I feel like there's a lot of ideas floating around without any visuals. The line that they gave us was this thing. The line that we found was this one, the tangent line. Okay. And then the point that we had to figure out was the point 4, 16. Here is that point. So the green is a problem, obviously. They gave us that red line and said, they asked us to find a line that is parallel to this line, but also tangent to the graph. So that restricted our choices to being really only the blue option. So we knew that the is going to be ax. We knew that from the beginning. We just have to figure out what this intercept is going to be. So in order to do so, we need the point that we're going to go through, right? And in order to find this x value, we had to use the derivative instead of equal to the slope. So that was the thought process, right? So we found the slope. We set the derivative equal to the slope and solve for x. That x was used to find the y. Once we had x and y, we can find our equation. And really all that was missing was this b term. Because we had the m and we had pretty much everything else. So tangent line. Any questions on this problem? I feel like this is one of the harder ones in that section. Okay. So last idea for this section is differentiability. So this theorem is pretty important from your book. So it's called differentiability. Continuity. Give me one moment. Oh, I see. Okay. If f is differentiable, at x equal to c, then f is continuous. at x equal to c. So basically this is saying that if you can take the derivative at a particular point, then you are continuous at that point. So the derivative implies that you're continuous. So there's some functions where you cannot find a derivative, like if it has a kink or like a sharp edge or a cusp. Let me show you. F of x equal to x minus 2, like this guy. If you were to use the limit idea, this is an absolute value function, right? It's has a little V shape. See how it has a sharp corner in the bottom, the little peak or whatever. That you cannot find the derivative at that point. You could try taking the limit at this point using the limit process instead of the shortcut, because the shortcut doesn't really work on absolute value types. So you would take the limit and you would end up with the different values for the limit on either side, coming from the left and coming from the right, which implies that the limit does not exist, meaning the derivative does not exist at 2.
For absolute values, those the two lines on this, does that just mean the same flips inside, right?
Yeah, it's absolute values with x minus 2 inside. Is that what you asked? I'm sorry.
I was just like, I forgot like how it works. Absolute value. This when you're like working with it, does the sign inside like negative turn to positive?
Oh yeah, basically anything you plug in after you add up whatever's inside must result in a positive. So if I plugged in negative 10 in here, that'd be negative 10 minus 2, which is negative 12. Absolute value of negative 12 would be 12. So no matter what, it's always just swapped to the positive version. If it's already positive, then it just stays positive.
Thank you.
Yeah. Okay. So as we were saying, right, this theorem said, if f is differentiable at x equal to c, then f is continuous at x equal to c. We are not differentiable at 2. Are we continuous here though? What does logic say? Right? I can't just say, the statement said, if this is true, then this is true. It doesn't say that if this is false, then this is also false. That's not how logic works, right? So technically at that absolute value, I am continuous here, but I'm not differentiable. So I can't say the converse. I can only say the straight up one directional statement. Okay. Just wanted to point that out and just in case it comes up. Okay. So the only thing you can say is if you know for sure it's differentiable, then you know for sure it is continuous. If it's continuous, you do not know if it's differentiable. It only goes one direction. That's what I'm trying to say. That makes sense?
Yes, sir.
Okay. That's pretty much it for this section. Let me see. So here in number 12, it's asking you where are we differentiable? Like, well, as long as it's not, as long as the limit exists, right? We know where the limit does not exist here, right? At -3, because we're going to two different directions from the right and left. Over here, different. So we're not continuous here. But we are differentiable everywhere else. Anywhere else is fine. So you would say you just exclude the points that have no limit, because the derivative technically requires a limit. Therefore, if there is no limit there, it is not differentiable there, which means it's not continuous there, because it also violates the rules of continuity from, was it 2 sections ago? So just remember the limit idea. You can either use the continuity idea or just look at the limits, see if they're the same. Okay. This guy here, where is it differentiable? Well, wherever the function is different is defined at, right? I don't see any weird cusps or V's or anything, no strange shapes, no holes or asymptotes. So from here till forever, -1 till infinity, we can differentiate. There's no problems. This guy here, it is not differentiable in the center because the limits would be different. And since it's not differentiable, then it's not continuous at that point. So now we have another tool to like kind of underline the fact that it's not continuous. But every point before this point, we can differentiate. Everything after, we can differentiate. Okay, that's pretty much it for 3.1. Do you have any questions on 3.1?
Not that I can think of.
Okay. Let me check the syllabus real quick. I keep forgetting to tell you guys, I posted an extra credit assignment. I don't know if I told you or not. It's at the right below that little voting thing.
Yeah,
The thing of the cars, right?
Yeah, if you just do it as soon as possible before October, and you should be good.
Was it required? Because it said it was required right next to it, and I was like, damn, okay, you're gonna require me to do extra credit.
Well, I'm required to make you do it. I am not required to give you extra credit. So I'm
Oh,
trying to,
damn, that's messed up.
so I'm trying to motivate you. That's what I'm trying to do. Because it's
I
not,
mean, I did it, but I was like, damn, how are you gonna force you to do extra credit?
because it doesn't have to be extra credit.
Right, gotcha.
Yeah, it's just the school requires that we do this assignment every fall for all the math classes. I think I don't know if all the other disciplines do something different or similar, but I know we're required to do it every fall. So every fall I make sure to reward you guys for being forced to do it.
Okay. So we'll be able to complete the 3.1 homework with stuff that we did today, and we'll have to wait for the next class to learn any other different theorems or identities.
Yeah, because 3.2 is actually they actually are doing just the power. They go more in depth into the power rule and the constant rule. So 3.2 is basically going to be the shortcut I just showed you, but more in depth. 3.3 is when they show you a more advanced technique. 3.4 is the one you need to do that square root.
Okay.
That's your square root shortcut. Let's see, but let me check the syllabus real quick before we see if we're ahead or not. If we are, maybe we can call it a day. This is, yeah, we're good. You guys have any questions about test 1 or chapter 2 topics? No, I'm not gonna start 3.2. I'm gonna do that next time.
When are you gonna grade test 1?
It hasn't closed yet, I don't believe.
Okay.
Close when, right?
Let me check. It closes, yeah, the 15th, so I'm not gonna start grading till sometime after that.
I actually had a question for for the test review.
But what about the review? Is there a particular problem or just in general? Or-
Yes, particular problem. It was for 10. I had done 10. Actually, is that the one thing? I don't know. I got a few questions on these, like 12 and 10.
12 and 10. Let me see. Hold on a second. Let me
I
open it
think
up.
10 I got it right, but then I came back and tried putting in, and then I got it. I think I might have gotten it right, but I just put it in wrong. But I think definitely 12 for sure.
Let's see here.
I think I asked you about that one last time.
Which one was
But
the
I-
12?
It was like asking for the limit, and it's like x is the going towards -7 from the positive side, and
Oh,
1 over x
yeah.
plus 7. But it's supposed to be like the opposite. Like the answer was supposed to be the opposite of what the limit's headed to. But I put it 7, and it was like incorrect. I was like, wait a minute. And I just
Yeah,
got
you're-
really confused.
Yeah, you're approaching -7 from the right.
Mhm.
So let's look at the graph really quick. Okay, so it was 1 over x plus 7, right?
Yes.
Okay, so I'm gonna just mark x equal to -7, so it's more obvious to everybody. So that's the asymptote, right? So the limit from the right is going to infinity, limit from the left is going to -infinity. So the limit does not exist because they're different, but they asked for, what the hell is it? They asked from the right, correct?
Yes.
So from the right, it should be infinite.
So if you didn't positive.
Yeah, positive infinity because it's shooting upward.
Oh, okay. And like during the test, we can remember if it said we use Demos or not? Or
Yeah, so what I'm gonna do is on question 1, I'm gonna have a little link here that says Desmos. Just click it and it should open a tab inside your respondus. I'm
Wow.
gonna actually, no, I don't think I should do that. You'll see it when you get there. That's the only way to get it to turn on. So I have to first allow it and then I have to plug in the link somewhere. So once you click it, you can use that link for all the questions if you want, or whatever questions are helpful.
epic. Also, I got like a couple. I've done it like 3 times, but I wasn't sure. Like, I don't know how many times we can attempt it, but I just wanted to know, like, right? Because number 1, I think you said there was something wrong with number 1. I don't remember what you said the answer was, but I think you said there was like you said you would grade it on the test.
Number 1, question 1, you said?
Yes.
Darn it, I closed it by accident. 1 second. Yeah, I was saying, I don't really care what the multiple choice answers are. I'm just gonna look at your work. And if you explain yourself correctly, you'll be fine.
And then for
but-
number 3, I didn't
Number-
understand that one at all. I don't know if I don't know what it's looking for. It says answer with commas. So like I thought the answer would be like, I don't know if you have the same as me, but it's -1 comes from the negative side, then -1 from positive side. It looks like it goes to -2 and -6. So I wasn't sure if I put in -2 comma 6.
It should be -7, -2, -7.
Oh, you're right, -7. Sorry. Well, and would that be like the full answer for that one? Or
I
would there,
mean,
like,
that's
like a-
the answer, but then you need to show your work, right?
Yeah,
Or at least some sort of explanation.
yeah.
Yeah, if you-
then,
Hmm.
I was also I think I number 11 was kind of tricky. Asking for the limit that's approaching -2, which is 1 over -2, or x plus 2. And that one,
So remember,
I
limits from
think,
the left and right have to be the same, right? Otherwise, there is none.
yeah. So like from the left, if it was -2, it would equal 0. And then from the right, if it came, it would equal 1 over 4. So I would think that it's anywhere.
Yeah, so from the right, it shoots off to infinity. From the left, shoots off to negative infinity. They're not the same. 1 over x plus 2, right?
Yes.
Yeah, so the limit does not exist because they are not equal to each other. And the right side is infinity, or the left side is negative infinity.
And that you could just see on Desmos, right?
You can see that, yeah, but you'll have to write that out and explain it.
Yeah. And then I think I totally got this number 10 one down. I'm pretty sure I just put in the wrong answer for it.
Number 10.
It's the one where you gotta use conjugates, where like you would,
conjugates. Yeah, it
yeah,
should have
where you
been
have
one
to, like-
half.
huh?
The
One
answer
half.
should, yeah, it should be one half the answer.
Could you like do it again just one more time? I just want to make sure that I get that one right. Like I feel like I did it right. At the end, I was kind of confused on whether or not, because I think usually it ends with an X on top,
Mhm.
which makes it a 1. But I don't know.
We
Like,
did that one, right? Or no?
yeah, I'm pretty sure we did that one. I was just trying to make sure because I don't remember if I wrote it down or not. I don't think I wrote it
Let me
down.
check the notes really quick. That was. Give me one moment. No, that's the spring. My bad. Fall. Yeah, we can go ahead and do it. I can't seem to find it anyway. Thought we did it. I think we just did something similar, maybe. That's what I'm thinking of.
Yeah, I think it was very similar. But I mean, I think it's very similar. I know I think I somewhat can do it. It's just that end part that I was kind of confused.
Okay, let's do it. 1 second. It's getting dark in here. All right, so let's just skip to the work. Exam review. What number was it?
Number 10.
Number 10. So the limit as x approaches 0 of the square root 1 plus x minus 1 over x. So you said you multiply by the conjugate, right?
Yes, sir.
Okay, let's get straight to it then. It's too far. So then we get the limit as x approaches 0. Up top, we're going to get a conjugate pair, which will give us these two terms squared. And then the bottom will be just this, right?
Yeah.
So then the top becomes something a little prettier. 1 plus x minus 1 over x times this nonsense. Leaving me with x and x. So these cancel, leaving me with just a single 1 on the top. When something cancels, it leaves a 1. Now we take the limit. So you take the limit, just plug in the 0. The 1 plus 0 is 1. Square root of 1 is 1. That 1 is still here. 1 plus 1 is 2. And that 1 is right there.
Okay, I see. So it's x.
Hey, sir, I don't know if you were continuing that question, but I had a question for you.
What's going on?
So I'm not sure if this will pop up on the test, but one of these questions that I saw was like, so basically it's an equation. The question is like, oh, prove there is a value between like a number and a number. I don't exactly remember how to approach that. So I was curious if by chance we could like go over something like that.
Was it the intermediate value theorem stuff? Is that
I
what you're
think
talking
it
about?
is because it's like 3x minus 7 equals 1. Prove there's a value between 1 and 3.
Yeah, it's not. It is on the test, but I'm not gonna test you on that. So I'm gonna have
Okay.
you skip it.
Okay, cool. No problem.
But yeah, don't worry about it.
And the lockdown browser that you're using, it's just like that regular one that I've only ever used one, but you just go in there, you log in, it takes you to the lockdown browser, and then there's the link in there to Desmos already in the browser, right?
Yeah, it's inside the exam. So
Okay, cool.
question 1 will have the link on the actual link in there. Just click it.
Okay, cool, for sure. Thank you. And is it 10 or 12 questions?
I don't know. Let me check.
Oh, okay.
I forgot already. Let's see. Yeah, 10, but like the last 2 are things I want you to skip.
Okay, cool.
And you'll see the Desmos link in there all over the place. I'll double check that it's turned on real quick.
So Professor, the last 2 we just don't do on the test? Like, or will it say something on there?
Yeah, I'm just gonna give you everybody credit for the last 2. So
Oh.
don't waste your time on those. Just don't worry about it.
Oh, okay. Thank you.
Mhm. Let's see. You guys have any other questions?
No, are we about finished?
Yeah, that's all I'm gonna do for today. I'm gonna wait for 3-2 for Wednesday.
Okay. Is it okay if I take off? I need to take care of my kids.
Yeah, if you guys are done, you are welcome to head out. I don't have any more material for you till Wednesday.
Okay, thank you. Have a good night.
You too.
I had a question, but for after class.
Okay.